So so welcome to the seventh lesson in our series. The today's lesson is about AI agents. Before we start with the today's lesson, if anyone can answer the question I posted from the previous lesson, that would be great. The question is how to evaluate a RAG pipeline. You can come off mute and answer the question. Anyone? Okay. Let me let me answer that. So you are all able to hear me, right?
Yep, you're good. And we can see your screen.
Okay. So as discussed in lesson 6, to evaluate a RAG pipeline, we use an LLM. We use LLM as a judge approach to evaluate the RAG pipeline, right? Um, as you can see here in the code, we used GPT-4 or Mini to evaluate our RAG pipeline we built as part of lesson 6. And there is a faithfulness evaluator and relevancy evaluator. For that, we pass our LLM, and then and then we get the basically we are getting all the responses from the RAG pipeline. Those responses are fed to evaluate underscore response function along with the query. Then it gives the results. And we look at the faithfulness score and relevancy score. If it is close to 1, then our RAG pipeline is actually great. And so, okay, let's jump into lesson 7 now. Okay. So this lesson is about AI agents, about building autonomous systems. Agent is where, given a task, it'll interact with external tools, execute the code. Code will be executed in the external tools, but the LLM will interact with external tools in order to get the code executed if required. And the result from the tool is fed back to the LLM, and then LLM use the result and iterate it. If it requires to interact with the tool again, it'll interact with the tool again and reads the response. If it thinks that it has all the responses to reason the question, then it won't interact with the tool and provide the answer. So agent is basically interact with external tools, right? The LLM is basically just answer your question. If you give a question, it'll answer your question, right? But agent interacts with external tools in order to answer your question. So that is an AI agent. So we'll look at building a small agent as part of this lesson and building a simple ETL agent where it'll analyze the data from a CSV file, and then small agents is something you can explore by yourselves. And then we'll look at how to use agent mode in GitHub Copilot. GitHub Copilot is like coding assistant or paid programming tool available for developers to use agents while doing software development. So so yeah, let's jump in. Any questions until now? Okay. So so you can see over here. So AI agent is an autonomous system that can use external tools to achieve specific goals. The difference between an agent and traditional LLM is that basic LLMs just answer the questions, while agent is able to perform actions using tools. That's the reason agents are becoming popular recently. It breaks LLMs out of the text in, text out box and lets them interact with the software world in an interesting way. So, so this is a picture which tells what agent can do, right? So, user is passing their query to LLM, and LLM will reason the user question, and if the output after the reasoning is that it has to interact with a tool, external tool, then it will send request to the external tool. External tool will execute the agent's request and give the result back to the agent. Once the result comes back, agent will reason again to see if it has all the required details to provide response to the user. If it has all the required details, then it will provide the response. After its reasoning, it thinks that it has to again interact with the tool, then it will send request again. And tool will execute the result and send the results back, right? So in the reasoning step, it may interact with the tool multiple times based on whether it has all the details to provide response to the user or not, right? If it requires to interact with external tools 10 times before it has all the data to answer the user's question, then it will interact with the tools 10 times in a repetitive mode. And at the end, it will provide the response, right? So um, this is how agents work, right? They work the framework called reasoning and acting. So acting is basically interacting with the external tools. Reasoning happens within the LLM to see if it requires tools access or not, right? So then sorry, there are tool-based agents, there are code-based agents. Okay, I see the question from Jenny. I think the tools are some kind of functions. So I think, yeah, the tools are some kind of functions, right? Let's say you have a Python project where 100 functions are there. in the whole project. And if you are asking a question to the LLM by referencing your whole project, then based on your question, it'll understand which function to be called and then call the function. So, um, yeah. So, tool-based and code-based agents, right? Tool-based agents interact with the world by calling predefined tools that are explicitly enumerated to LLM. Basically, we tell the LLM, we provide context about all the tools we have uh, for the LLM to use in the prompt. Um, so those tools will be used by LLM. So this is an example of tool-based agent. So the code-based agent takes this idea one step further. Instead of selecting from fixed list of tools, the agent is allowed to write and execute code to reach its goals. So agent writes code, runs it, inspects the results, and then decides what to do next. So this is how code-based agents work. They write code as well for you. Right? This is extremely powerful and flexible, um, but it requires guardrails to keep things safe. I have experience of using agents to write code in my iOS programming. So if your prompt is not correct and it if it doesn't have guardrails, then it'll go and implement something which is altogether different, which is obviously not required, right? Um, it may misunderstand what you're asking for, and then it'll do a whole lot of implementation. It'll write code. Let's say sometimes it'll write 3,000 lines of code as well. So think about a situation, it has written 3,000 lines of code and it's obviously not what you are looking for, right? So guardrails are really required when you are using code-based agents, right? So there are frameworks to build agents if you want to build your own agents, right? So Small Agent is a lightweight framework from Hugging Face that emphasizes simplicity. It is it is suited for Core Dream. They mention here because it's simple and Pythonic and flexible framework and is extremely powerful. And LangChain, LangChain is very important. LangChain also can be used to build agents. If you look at the job descriptions, right, definitely most of the data scientists are Gen AI or AI agent developer. All those job descriptions will ask for LangChain mostly. So two concepts people look for in the candidates while appearing for job interviews is basically the RAG pipeline, how to create a retrieval augmentation generation, and using LangChain to create agents. Right. So you can use LangChain to create a RAG pipeline too. That is not discussed in the class, but you can explore it further if you want. In our class, we discussed about using Llama index to create a RAG pipeline, but LangChain also can be used to create a RAG pipeline, right? So, so LangChain is a general purpose framework for building LLM applications, including agents, right? If you remember, we built a chatbot earlier. We used ChatGPT LLM to create a chatbot, right? Let's say you want to, let's say you built a chatbot by using ChatGPT LLM underlying to make API requests, right? And after a few days, you want to change the LLM to Gemini, then you may have to make the code changes so that your program works with the Gemini LLM, right? And let's say after a few days, you want to change it again to Anthropic Claude LLM, then you need to make code changes again, right? Um, but if you use LangChain, right, it is seamless if you want to move over to different LLM, right? Because LangChain is a wrapper, the same code works for different LLMs, right? You use higher level functions, but the underlying functions will basically customize to work with any LLM, right? So that's why LangChain is basically used widely. So LangChain provides many tools for building production grade systems quickly. So you can switch between LLMs if you create if you use LangChain. Um, but the trade-off is that it is little complex. It is a complexity of the framework. Um, so that's the trade-off with the LangChain, right? So these are the examples of the of frameworks available to build agents, right? And then for agents to work with, there should be some standards defined for agents to interact with the tools, right? There should be some kind of abstraction layer, defined abstraction layer, so that it brings consistency to interact with the tools, right? So, um, more model context protocol created by Anthropic is an emerging standard that defines common interface for interacting with the tools, right? So it's a protocol that standardizes how agents discover tools, understand their inputs and outputs, and calls them safely, right? Much like a USB standardizes how devices connect to computers, right? So the USB connectors are standardized so that multiple computer manufacturing organizations use the standardized USB ports so that it works with all the USBs, right? So it's a standardized. Similar way, how agents interact with the tools, right? Um, let's say there are multiple agents and multiple tools. There should be some standard way for interacting with the tools for agents. That's what is a model context protocol provides. So then let's move to the first agent, the minimal agent. We'll look at how to build a simple agent. Okay. So as mentioned, the React framework is used to create agents. It involves reasoning step and acting step. In the reasoning step, LLM uses its reasoning capability to determine whether external tools are needed to answer the query. If it decides external tool is needed, the acting step is initiated, wherein a tool call is output that requests the result of a given tool. So if it thinks that a tool call is required to be made, then acting step is initiated, right? LLMs use the result of the tool call and generate the response. If a tool call is not necessary, it will directly generate the response. The loop continues as long as it needed till the agent determines the task to be completed. I think we discussed this concept just now. Um, so LLMs cannot run code. LLMs can only ask tools to run the code. Tool is run externally and the result is sent back to the model, right? In a case where an external tool is needed, you need two API calls per query. One where model asks a tool, one where the model uses the tool result to answer user's question, right? Um, so here is the implementation. So we'll load the OpenAI client. I think you know this already. You might have done this multiple times by now. So here is a simple task. You were asking an LLM about what is the current time right now. Then this is the prompt. User prompt is what is the time right now, right? System prompt is you are a helpful assistant. And we are calling the chart completions API, and we are passing this prompt, and we are observing the result. So in the result, it will say, I'm not able to access the real-time information. It is telling you to check the time in your system, in your laptop, or through some online service. Because it doesn't know how to interact with your Python program to answer your question about what is the time now, right? So this is a simple example. Now we'll look at building an agent for this, and so the agent will interact with your Python program and provide the time for the user, right? So um, for that, we are writing a Python function which outputs the current time. So the function name is get current time. It basically takes the current time and outputs it, basically returns the current time, right? So if you call get current time, it's printing the current time. So we have written this Python function now. This is your tool definition now, right? So for the model, we need to pass the tool description, basically the function name, function description, and the parameters it take, right? Function name is get current time, description, basically natural language description to help the model to decide when to call that function or a tool, right? So this is the tools object we are creating. It's a dictionary type. We are saying function name, get current time, description, parameters. It doesn't take any parameters. So properties empty. So there are no required parameters in this function. So required is also an empty array. So now we created the tools dictionary in order to make the LLM aware that these are the tools it can use, right? Um, now, now we want LLM to use the get current time tool whenever it requires to access it, right? So we'll look at implementing the React agent. So you send a chart request to the API. You tell the model what tools are available using the tools parameter in the API call. So you can see over here, um, again, the same system prompt. You are a simple assistant that can tell the current time. Use the tool when user asks about the time, right? So we are passing the system prompt here, the user prompt for the role user, and we are passing the messages to the completions API, and we are passing the tools object too. The tools object is basically the list of tools available for the LLM to use, for the agent to use, right? So, and we get the first response. And we append the response we get to messages. We are appending the role, the content, the response we got. We are appending the tool calls as well. From the response, we are appending the tool calls as well to the messages, right? And then here is where we are iterating over the tool calls. Let's say tool calls are 3, then we'll react for 3 times in this loop. Means we interact with the tools 3 times. So for each tool call, we are basically if the tool call function name is get current time, we are calling the get current time function, right? And we append the tools output. Tools output to the messages. Um, and then we make the second call to get the final answer, right? So let's see here. So model look at the conversation and decides the reasoning step to either answer directly or return a special tool calls field. A tool calls is the model saying, please run this function and tell me the result. Right. So we are sending a query to an LLM. It will reason it, and if it returns a tool call, then basically it is telling to run the tool, run the tool, and if the tool call is not returned, then it will answer the answer directly. If the tool call is required, it will run the tool and then receives the response, and then again make an LLM call to provide the answer. So yeah, this is the code for that. While we make the API call, we are passing the tools object and tools underscore choice. We are saying auto. That means we are deciding model whether model chooses whether to use the tool or not, right? And then we check if there are any tools. If tools are there, then we make tool calls to Python functions and then make the second API call to get the final answer. So yeah, basically the steps are explained here uh, sequentially. We are making the first call. If tool calls are present, it runs the corresponding Python function as part of the tool call, then make the second call to provide the output or result to the user. So here is an example. So you were calling run agent function. So the run agent function is what we have written here. We are passing the user prompt. So you were asking what is the time right now. Then if you inspect the sequence of the logs, first response received, it has tool calls in the first response. It tells which function to call as well. And then, the tool is called, then agentic mode is engaged because it tells it needs to use tool. Agentic mode engaged and tool called, result came back. Then make a second call to the LLM. Right, in the second call, we are passing the timestamp or the result of the tool, actually. Then we get the final response. So in the second case, query doesn't require tools usage. Let's look at the query. Query is explain what an LLM agent in 2 sentences. Obviously, for this question, LLM doesn't require tools access. It can just provide the response based on the knowledge it has, right? So no tools access needed, so it directly provides the response. It's not interacting with the tools. So this is an example of building a simple agent. Okay. Then we'll look at quickly about how to create a data analysis tool agent. It's a similar concept, but here there are more number of tools. In the previous example, there is only one tool, but here there are more number of tools, right? So this is your CSV file which needs to be analyzed. So we want to build an agent which analyzes the CSV file and provides the response, right? So use case is to create a data analysis agent that read the CSV file, analyze the data using set of tools, and yeah. So this is the CSV file. It's in the resources folder. In the resources folder, bike_commute.csv. And here is the example of the data set. It has distance in kilometers, duration in minutes, average speed, heart rate of the driver, I think, traffic density, and chances of rain. Right. So this is the data set, general setup. So defining external tools, right? There is a CSV manager call. These are the internal functions. Normalizing the CSV file name function. This returns the available CSV files in the location we provide. This function makes sure the CSV files are loaded, right? So those are basically general functions required. And then these are the tools we are creating for the LLM to use or agent to use. List CSV files is one tool. It basically lists all the CSV files. Load a CSV file is one tool. Load a CSV file from resources. Right. Get columns. This gets all the columns within the CSV file. Summarize columns is another tool. This summarizes all the columns in the CSV file. And then describe columns. One more tool, plot data. Plotting the CSV data is another tool, right? So these are all the tools we created for the agent to use, right? And then once we create the tools, definitely we need to provide the tools information to the LLM so that it aware of all the tools it can access to and use the right tool based on the user query, right? So again, this is the description of the tools we have seen just now. Um, so we are defining the tool schema here. It's the same way as we did earlier. Tool schema for all the tools we have 6 tools. For all the tools we have, we are basically creating the schema. Type, name, description, right? And for load CSV tool, so properties file name and the property type string required. File name is required. So if we go to load CSV function, it takes file name parameter and it's a required property. So accordingly, the tool schema is created. So you can see over here, load CSV is the tool name. It has a property file name, which is of type string and it's required. File name property is required. So we create tool schema and then run agent underscore cycle. It we are passing the messages user text and maximum tool rounds is 5. So for agent, we can set how many times it can access the tools, right? This is for cost cutting. If the maximum is not there, sometimes agent can go in loops, right? It may go in loop of 100 times. It can interact with the same tool 100 times sometimes if our prompt is not correct. And the side effect is that you will be charged more because you know how LLMs charge, right? With the agent mode, it is giving responses for each tool call, and for each response, you will be charged, right? So setting maximum tool rounds is basically a kind of limiting the tools access to these many times. And once it reaches this, then it won't access tools anymore and gives the response. So reason, act, observe, and stop. Stop condition. I think when when the mis when the when LLM has all the data required and it doesn't require further tool calls, then it will stop. or if max tools rounds is reached also, it will stop. So it's the same code actually. Observe tool result function returns tools return value as a message that can be appended to the LLM's conversation history. So for each tool call we make, we get a response from the tool, and that response is appended to maintain the conversation history. Right. So this function is to run through React agent loop using simple tool using agent. Messages parameter usually systems prompt, and the user text is basically user's prompt, right? And then yeah, the same thing we are iterating and then calling the completions API. If it has any tool calls, then it'll go and access the corresponding tool, right? Iterating over all the tool calls. In our case, in this example, there might be multiple tool calls required. So it'll iterate on each tool call and make a call to LLM, um, and append the result to the messages at the end, right? Here is the system prompt we are giving. You are a small data assistant for CSV files stored in the sources folder. Use the available tools to do any data work. Do not guess. If no CSV is loaded, load one first. Keep answers short and student friendly. This is a system prompt. And run agent function, we are passing the system prompt and also the user prompt, right? The user text. So we are calling the run agent cycle function, which we created here, passing the system prompt and user prompt to it. And yeah, we just call run agent function. So here is an example chart. You we are asking this question to LLM. CSV data agent at your service, here to help. Look at your CSV data, type your question, type exit to quit. So first query we are giving is list all the CSV files available to you. Then, so it'll call the list CSV files tool and provides the response. Um, right. And then user query, yes. So it is giving the response. There is one CSV file available. Would you like to load it to explore its content? It's asking you if you want to load the CSV file. Then user is saying yes, go ahead. Then it'll access the next tool to load the CSV file, and then it's loading the CSV file and it's saying it's loaded. Then it's asking what would you like to do next, and user is saying summarize the columns in the loaded CSV file. Then it's calling the summarize columns tool and it is summarizing, right? So likewise, it is able to access the tools. And next it's asking, let me know if you want details or any specific analysis, right? And then user is saying, plot the relationship between average speed and average heart rate. Then it's accessing the plot data tool and then plotting the data, right? So this is an example of building a data analysis tool, right? And The small agents, I think this one you can explore by yourself and understand it. And the final concept is GitHub Copilot. So Copilot is a paid programming agent that can look over entire code base and help you write, fix, and improve code. Right? It can work with VS Code or Xcode, other IDEs basically, in order to help the programmer, right? Um, so I can let me see. I can quickly show you. I have Visual Studio Code. I can show you how to put it in agent mode and then um, so I'm just opening up some sample project. So you need to download the agent, not agent, the Copilot. It's an extension in VS Code. Let's see. Yeah, GitHub Copilot chart. So this extension you need to install in VS Code, and then when you click here, once you install that extension, this is where you need to click. When you click here, that extension is open here, and here is where you can ask your question, right? Um, and there are multiple options. Ask is one option, agent is one option, plan is one option. When I keep it in ask and ask the question, it will not interact with the tools. It'll just answer the questions we are asking. But if you keep it in agent mode and ask the question, if you ask it to write code, then it'll go ahead and write the code as well for you. It'll basically interacting with the tools to write the code. It'll write the code, and then it can even execute the code to make sure there are no compile errors. If there are any compile errors, it'll read the compile errors and try to fix it. To fix it, it'll write the code and then again compile it until there are no compile errors. It'll go keep on fixing the issues as well. So that is what the agent mode can do, right? Um, so nowadays in software organizations, in enterprise organizations, they're using the agent mode to generate the code. So it'll generate the code, it'll fix the bugs, compile errors, it'll write unit tests. So it's doing all those things, right? So I just want to show you about where is the agent mode and how to use the agent mode in the GitHub Copilot. And you can choose the model you want to use as well. So I usually use Claude Sonnet models, basically Claude models. Claude models are good at writing code, um, but you can choose which model you want to run. The model costings also mentioned here. If you don't want to use the agent mode, just you want the LLM to answer your questions, then probably you can use some GPT models as well. GPT models are low cost model, right? So so the model costs are mentioned here too. So you can select which model to use and then put it in agent mode or ask mode and then use the copilot. So it shows the same. It has the same thing here, like how to install the GitHub Copilot and putting it in agent mode and choosing the LLM to run, etc. So I think That's about it for today. So I see one question from Jenny. Do you have any resources where we can learn to incorporate a chatbot into a web page? So I think I need to check if there are any documentations on this, but let's say you have a web page built, right? It's basically interacting with LLM is basically right, making an API call to the that particular LLM, right? As we saw in our lesson. Um, so in our AI intro, we saw about chatbots. So building a chatbot is about making a call to completions API. So the client is an OpenAI client, and it's basically about appending all the history, all the chart history, and then sending the chart history to the completions API to get the response. So I think it's straightforward. You just need to use this code in your web page. If you have a web page, right? Let's say you have a button where you can initiate a chart. When you click on that button, it'll open up a chart window. It's basically a UI, HTML or some front-end UI. And you will give a text box, right, in the UI, and in the text box user query is kept. And when they hit on submit, you take the user query. Basically, you read the user query. Uh, it's tied to a Python function, right? Whenever they submit, a Python function will be called and user query will be taken from the UI, and you can call this underlying function where it makes call to completions API, right? And you pass the user message, and you're getting the response here, and that response you again put it in the UI, right? That is how you build a chatbot. So I think it should be straightforward. You can just give it a try. If you have a simple HTML page, if you are using Python code for backend, then read the user input in the Python code and then make an API call to OpenAI model, get the response once you have the response displayed in the UI. So that's all.